Hi everybody, my name is Sofia Lopez. I'm here in Baptist Hospital along with a former student from Kaiser University, which is now an employee in the radiology department. He's here to help me further explain AEC Chambers and everything you need to know about it. First, he's going to talk about photo timers versus ionization chambers, minimum response time, backup time, density control adjustments, alignment and position considerations, compensating issues, and collimation. And here I present to you Armando Lopez.
We're here at Baptist Hospital. My name's Armando Lopez. I used to be a former student. I was right in the seats where you guys were. So today we're going to be talking about AEC Chambers, which is basically right here in front of us. You can see that this is one of the setups that exists, which is a 3-chamber setup. And basically what it stands for, AEC, is automatic exposure control. It can also be seen as AED, which is automatic exposure detectors, for obviously the detection here. And this comes in a setup of either 3, how it is here. You have some that are 5 chambers, and you have some that are 7 chambers. Okay, so to continue, we used to have, you guys have probably heard the expression, oh, photo time, just use photo time. In reality, photo time is actually an outdated expression. We don't really use photo timers anymore when we talk about AEC chambers. What we do now is we use just the chambers, and once they get ionized, once they're filled up, then the exposure is cut off. So basically what they had before is that there was an extra step. So you would do the exposure, then there was a photo timer behind this that would pick up the x-rays, turn it into light, and then that light would turn it into, I want to say, an electrical current, which would then tell the machine to shut off the exposure. So obviously if you think about that and there's an extra step, there needed to be more exposure time for there to be enough light, or there to be enough conversion of light so that there was enough light to make that current. So basically they cut out the middleman, and now it's just an ionization chamber, which once it has enough ionization or a charge of electrons, the chamber will shut off automatically. And that obviously reduces the patient dose. So we've progressed in that sense. Okay, so as far as, I guess I'm going to talk about a little bit what we can control as far as a technologist. We can control still the KVP when we talk about AEC chambers. We can still control the MA. What we don't control is the time. Obviously the time would be depending on the patient's body habitus and how fast the chambers get ionized. So what I want to talk about basically is, another thing you guys need to know is the selection of these chambers. So when you do a regular, for example, we'll just stick with the PHS, we're going to select these 2 detectors right here, left and right, we'll call them, not the middle one. So I want you guys to think about, just for a second, a quick little quiz question. What would happen to an x-ray of a PHS if you just selected the middle one? I want you guys to think about it for a second. Alright, so if we selected this, I talked about it a little bit earlier, you're going to have an overexposure of the lungs. Why? Because if we're choosing this one and we're lined up for a PHS, right, we're going to be going through all that spine and all that tissue, and obviously we know that takes a lot longer to go through than it does the lungs that are just full of air. So that's why it's very important to know what detectors to choose. Now the great thing is that a lot of it now is just on the computer. Obviously I can't show you guys on the computer here, but basically you would have either some type of buttons that you can press on a console, on a type of panel, or you can also do it on the computer where there's a button that you can select and you can choose what chambers. Now obviously for every study that you do, the chambers are pre-selected already for you for what it should be. So you shouldn't really be playing around with that too much because they're already set as far as, they're already pre-programmed for the studies. Alright, so this is one example of a panel. I think Sophia, right? Showed me, I saw a video of a panel. You guys have something similar right now in the lab. But as you can see here, this is where you would have the selection of the chambers. So you have the left, the right, and the center. Another very important thing that we can do is that you can tell the machine if you want a longer exposure. For example, you see here that you have, this is called the density control, and you have plus 2, or minus 2. So every time, right now it's set at 0, as we can see the light in the middle. Every time you move, let's say for example to the right, let's say you would go plus 1, you're basically telling the machine that it's usually set at 25% more density than what you would normally get for whatever study it is you're doing. This basically tells the machine, for example, if you're doing a chest lateral and you see that patient's a little bit bigger, you're probably getting a little bit more technique. If not, you're going to get an underexposed image due to the fact that you have to go through basically the whole patient side to side. So you can just increase this 1, you get 25% more, and you'll get a nice even exposure throughout the image. Okay, so the last thing we're going to talk about when we talk about AEC chambers is basically how, I guess, the machine interacts within itself. First thing is you have what's called the minimum response time. Usually this is set at, I believe it's 0.001 seconds. Basically what that means is that that's how long, once the chambers are ionized, how long it takes for the chambers or the detectors to tell the system or the tube to cut off the exposure. It's a very simple concept. It's just built in. And the other one is the backup timer. So the backup timer is set up for the protection of the patient, just in case there's a glitch, there's something going on. It's a backup timer that'll basically shut off the exposure, kind of like maybe you guys have seen in some X-ray rooms. There's a emergency stop button or a stop exposure button or something like that. It's built into the system, and it's usually set at anywhere, I believe it's 150% of the density that you would normally use for whatever exam you chose. So it's just kind of a safety feature that the system has, just in case anything were to go wrong. And I believe that's it. That basically wraps up all the basic things you need to know for the AEC chambers. Good luck, guys.
To conclude, we now know what an AEC is. It is an automatic exposure control device used to consistently control the amount of radiation reaching the image receptor by terminating the length of exposure. We know that it was known as phototimers before, and now they are ionization chambers. We know that minimum response time is the length of time necessary for the AEC to respond to the ionization and send a signal to terminate the exposure. Backup time is a feature that's important for patient dose and safety. Density control adjustments are necessary to permit adjustments of intensity necessary to terminate the exposure. We also know that collimation within an activated chamber will result in an overexposed image, or inadequate collimation may result in a light image. Lastly, target tissue must be accurately positioned, so positioning is crucial when using an AEC, automatic exposure control device. So that's it, everybody. I hope my video can help you also understand what AEC chambers are.